Okay, so today we're in 1.7 number properties, and actually I want to think about this expression that you see, 12 plus 4. Is there another way we could write this expression and it would be equivalent to 12 plus 4? I think you all know what that equals. It equals 16. So don't write this as 16, but how could you rewrite that so that it is still the same? Adrian? 4 plus 12. So we actually know that with addition, the addends can be moved like that. And does 4 plus 12 still equal 16? Yes. It's true. Let's look with multiplication. Who could show us that with multiplication? Does it still work? Yeah. 2 times 4, does it equal what, Michaela? 8. It equals 8. So how could you rewrite it? 2. Very good. 4 times 2. Does that still equal 8? Yeah. Yes. So we may move the factors, as long as they're all factors, and we have the same product. We may move the addends, and we have the same sum. So we've actually talked about this word already in 7th grade, and this property works for both addition and multiplication. You may move those things. And do you know the name of that property? It's about moving. Like when you left home today, you came to school. People are driving around, moving around, and it's called commutative property. Very good. There are actually 2 different properties. We have the commutative property of addition and the commutative property of multiplication. So, as we saw with addition, you can add numbers in any order. As a rule, let's see if you can finish this. I bet you all can finish this. A plus B equals? B plus A. Good job. So we just move the addends. Multiplication again, the order of the factors doesn't change the final product. And you're right, A times B equals B times A. So sometimes we use these properties to simplify our multiplication. Sometimes the order of multiplying or adding would be simpler if we move things around a little bit. Okay, so looking here, what's the easiest factors to multiply together here? I mean, a person could simply go from left to right, but really, what are the easiest 2 factors to multiply together here? 4 times 25 is 100. So he is commuting. And often students won't want to write all that out, but he's moving those 2 close together and then saving the negative 9 for later. Because 4 times 25 is 100, and 100 times negative 9. You want to finish it, Luca? What is that?
Negative 900.
Negative 900. Okay, so we're looking for ways to simplify our multiplication or addition. Let's try another one. Here we have addition. Which 2 addends would be easiest to add first? Do you see it? Matthew?
Negative 13, negative 7.
Right. What is negative 13 plus negative 7? Matthew?
Negative 20.
They're both negative, and we have negative 20. Good. And negative 20 plus 34 is? Excellent. That's where we had to subtract because they had different signs. And we only have to subtract kind of a nice number. That 20 is a really nice number to subtract from 34. There is not a commutative property of subtraction, right? So that means if I have 10 minus 6, I can't just move the 10 and the 6 and leave the subtraction there, right? Because 10 minus 6 does not really equal 6 minus 10. What is 10 minus 6, everyone? 4. And 6 minus 10? Negative 4. See, they're not really equal. So if I take 10 minus 6 and change it to addition, what does it look like, Matthew?
10 plus 6.
Actually, you can't just take 10 minus 6 and say it's the same if we say 10 plus 6. We would have to say 10 plus negative 6. So if I say that, now I can say negative 6 plus 10. I can move those 2 things around, and let's see if this is equal. 10 plus negative 6 is, and negative 6 plus 10 is These are equal. So we may move terms when it comes to addition. And yes, we'll collect like terms, but we do it always with addition, right? Okay, the second property today is the associative property. There's one for addition and one for multiplication. So when you think about associative, that word sounds like association, and that's exactly what it's about, an association. So we could say that your class, what, your 7M, 7H? So we could put parentheses around the whole 7H and say you're part of that group, right? But then we know that each of you has other things you're part of. You're each part of a family. So for you, we could take your parentheses, another parentheses, and group you with your family. So associative property is about how you're grouping, not how you're moving, but just how you're grouping. So we would say, let me see. Give me 3 numbers, Michael.
3 numbers, 3, 5, 7.
3 plus 5 plus 7. So right now, 3 plus 5 plus 7, we could find that sum by doing what first? What could you do first, Mark?
You could do 3 plus 5.
Okay, we could do it left to right. We could do 3 plus 5 first. And 3 plus 5 is 8. And 8 plus 7 is 15. So the other way we could do it is leave the 3 there, and we could just do what?
5.
Combine the 5 plus 7, right? Let's see, what is 5 plus 7? 12, and 12 plus 3 is 15. So did we change the order of the numbers from the left to the right? Is the order different?
Yes.
Let's look. We have 3, 5, 7, and 3, 5, 7. Order was not changed, only the way they were grouped. But did we get the same sum?
Yes.
It was all 15. So the associative property of addition says grouping your addends differently does not change the sum. And here we have it as a rule. Brianna, could you finish the rule for us? Okay, but we'll keep the order the same. So we'll say equals A plus, then she said use parentheses around B plus C, and that is correct. So the order is the same, it's just the grouping that's different. Does this work with multiplication?
Yes.
Okay, let's try it. Give us 3 numbers to multiply. Skylar.
7 times 5 times 2.
2. Okay. So if we just multiplied this from left to right, we could group these 2 together, right?
7.
And what is 7 times 5? And 35 times 2 is 70, right? Or, let's see if this works. 7 times, what is 5 times 2? 10. Is 7 times 10
Yeah.
70 as well? It works. Now, the order didn't change. 752 and 752. It's just the order that we multiplied changed. And so we can see that there is a multiplication property that is the associative property, or an associative property of multiplication. The way you group all your factors doesn't change the product. So Sophia's question was, if you have a bunch of multiplication and addition all in one problem, can you still do this grouping stuff? But we say you've got to remember your orders of operation, your PEMDAS. You're going to have to do multiplication first. So watch out when you see more than one operation and they're different operations. You got to remember your PEMDAS, okay? Very good. So we're, in this right side, we are multiplying B times C first. Okay, let's try this. And go ahead at home, try it out, come back and check your work with our answers here. Inverses, everybody say it. Additive, inverses. So if you just go ahead and throw new color parentheses around those 2. Have a new color? Can you reach it? Let me lower it. Whoops. You would be regrouping this one with this one. right? There and there. And you used what word to describe that? You said these two numbers will cancel, but we know that's the additive inverse, and they became 0. So what's your answer? 17. So there's no need to go add 8 plus 17, is there? Yeah, go ahead, write it down. 17 is the answer. Okay? Number 6. What would you do there? Describe it to us.
Cancel out negative.
Because those are also
Like this, inverses.
additive inverses again, right? And your answer is
15.
15. Good. See how nice that is? Okay. Now, Emma, come on up. Tell me which two numbers would be the easiest to combine together here?
47 and 37.
Probably, but 47 is negative, right? Why don't we change this to adding the opposite? Can we do that? And there you go. Beautiful. Am I recording? I've lost my recording bar. See that? There it is. It's still recording. Negative 47 plus 37 is negative 10. Great. Bring down 24. Beautiful. And 24 plus negative 10 is 14. Very nice. Okay. And so Emma noticed that multiplying 20 times 5 is really easy. Don't forget the negative though. One of them is negative, so we've got negative 100 times 43. And so your product is negative 4,300. Great. And there you go.